What if the central battleground for corporate competitive advantage isn't the final product you sell, but the invisible infrastructure you build it on?
Hmm.
What if the key to thriving in this hyper-digital age isn't about developing the fastest, flashiest application, but dismantling your own internal technical walls,
Correct.
turning your core functions inside out, and
Uh,
creating a stable, open foundation that allows partners, maybe even competitors, to build on your success?
that is the defining shift in the modern economy, and it really demands our full attention. For the past decade, we've watched technical architecture move from being an IT cost center
Right.
to becoming the central strategic blueprint for business survival. And today's deep dive is precisely about how these technical choices dictate innovation speed and really long-term viability.
Okay, so let's unpack this for you, the learner, whether you're studying business, information systems, or finance. Today, we're doing a deep dive into platforms, APIs, and modular thinking.
And this is not just abstract technical theory.
No, not at all. These are the fundamental architectural choices that will determine whether your future employer is, a nimble market leader that grows exponentially, or, well, a slow-moving legacy player constantly playing catch-up.
So our mission today is pretty clear. We're going to interpret how these architectural concepts, platform ecosystems, interoperability via APIs, and modular systems like microservices are no longer optional. They're fundamental, required capabilities for any digital era business.
Yeah.
We're linking the technical how to the strategic why, giving you the career-focused takeaways you need to understand the structural foundation of the digital economy.
And since we are sharing insider tips and analysis that can absolutely position you for a bright future in any of these fields, I mean, understanding this material is a huge career accelerant. Go ahead and hit that like button, subscribe, and share this deep dive right now. You don't want to miss the essential insights we're about to deliver. And as always, you can find links and additional resources we mentioned right in the description below.
So to really understand the stakes involved, we need a high-stakes, real-world example of what happens when strategy, this desire to innovate, and architecture, the system built to deliver it, are fundamentally misaligned.
Let's set the scene with Alpha Bank. So picture a large regional financial institution, solid, trustworthy, established, but running on classic legacy IT architecture.
Right. The old way of doing things.
Exactly. Their core banking systems were monolithic. And that means all the functionalities, customer records, transaction processing, loan applications, they were all intertwined in one giant, inflexible code base.
And the teams developing features were siloed, which, almost always mimics the software's internal structure.
The consequence of that was just crippling slowness. If the marketing department wanted to launch a new feature, say a faster online loan application tool, the developers had to navigate this big ball of mud, as they call it. Any small change required testing and redeploying the entire massive application. It resulted in incredibly long development cycles and brittle integrations that broke all the time.
And meanwhile, the market was just being eaten away by these agile fintech startups.
Yeah.
These newcomers were rapidly rolling out innovative, seamless apps for budgeting, investing, payment. And they weren't waiting for Alpha Bank to update its systems. They were often forced to use clumsy workarounds, or worse, their own proprietary systems, because Alpha Bank's architecture was inherently closed.
It was designed to guard information, not for open collaboration and rapid service delivery. And this inability to adapt led to a tangible loss of their most valuable customers, especially the younger, digitally native ones.
So, realizing they couldn't possibly build and deploy competing apps fast enough, the CIO took a massive strategic risk.
A huge one.
Instead of continuing to feed the monolith, they proposed re-architecting the entire bank into an open digital platform. This wasn't just a technical upgrade. It was a complete strategic overhaul.
Okay, so what did that look like?
They restructured their core software into modular services. And, this is the crucial part, they exposed key banking functions, like checking account balances or initiating payments via secure, standardized application programming interfaces. We call them APIs.
And that architectural overhaul, it fundamentally transformed the entire organization and its market position. Alpha Bank went from being a closed-off product builder, selling only its own goods, into a hub, a platform that fintech partners could actually build upon. It transformed from a pipeline into an ecosystem orchestrator.
Just think about the result. A local startup partner utilized Alpha Bank's new APIs to create a sophisticated personal finance mobile app for Alpha Bank's customers.
Wow.
This app offered real-time budgeting, spending categorization, and financial advice, all leveraging the bank's data with customer consent. It was something the bank's internal IT department would have taken a year to develop, if they ever got to it at all.
And internally, the organization shifted too. They started aligning their human teams with the new modular architecture. So instead of those siloed IT departments, they formed cross-functional service teams, each one autonomously responsible for a specific discrete business capability, like loan origination or customer authentication.
And the modular restructuring ensured that a problem in the loans module no longer meant taking down the entire system. Developers could update parts of the system independently and much, much faster.
This convergence of IT strategy and innovation, driven by a foundational change in architecture, drastically improved customer retention, attracted new partners, and unlocked entirely new revenue streams and business models.
And that shift from a closed linear pipeline to an open networked platform is exactly where we start our technical deep dive. Historically, for most of the industrial age, value creation followed a very simple linear pipeline business model.
Right.
You define a product or service, you own the entire supply chain, from sourcing to manufacturing to distribution, and you just push that product out to consumers. Think of Ford building cars, or, as we just discussed, a traditional bank creating accounts and delivering them directly.
It's a classic value chain model. Very linear, predictable, and fully controlled by the producer, which is effective, but it severely limits your growth and your innovation speed because the producer has to do all the work himself.
That's the critical limitation.
Yeah.
And the digital economy just broke this model.
Yeah.
Platform architecture represents a profound organizational and technical break from the pipeline.
How so?
Well, instead of owning the entire value chain, a platform firm focuses on orchestrating a multi-sided ecosystem of participants.
So you've got customers, third-party developers, suppliers, partners.
Exactly. The value creation is shifted from the firm itself to the network.
Which means the core business isn't selling a product anymore, it's facilitating interactions.
Precisely. The platform provides the foundation, the rules, and the interfaces, the APIs, for external parties to build and innovate upon. It's what we call a socio-technical system. The success relies equally on the robust technology structure and the network of people and organizations that the technology enables. It fundamentally redefines the structure of competition.
And the proof is just everywhere. This model isn't some niche thing, it's completely dominant. I mean, look at the global economic landscape. An astonishing 7 of the top 10 global firms now operate primarily as platforms.
Connecting multiple user groups and orchestrating these vast ecosystems.
And these platforms demonstrate just incredible flexibility. Think about AWS, Amazon Web Services. It began purely as an internal capability, the infrastructure Amazon built to run its own massive e-commerce operation. By making that infrastructure available to the world through standardized interfaces and APIs, they turned a massive internal cost center into the foundation of the entire cloud computing industry.
And it's used by millions of startups and enterprises globally. Or you could take enterprise software. Salesforce started as a single CRM product, a linear application designed for sales teams.
Right, a pipeline product.
But it strategically evolved into a broad platform hosting the app exchange. Now, thousands of third-party apps and integrations are built on top of the Salesforce core. Shopify is another great example.
From a simple tool to a huge commerce platform.
Yeah, with an entire app marketplace where partner extensions significantly enhance the value proposition for every single merchant using the service. They've leveraged the collective ingenuity of their partners.
So what's the power behind this? What's the engine?
The foundational power that drives these platforms is the network effect. This is where the physics of the digital economy really change. It's a self-reinforcing, virtuous cycle.
Okay, so break that mechanism down for our listeners. How does that cycle work practically?
Simply put, the platform's value grows exponentially as its user base and partner network grows. For example, if you join a social media platform, it's only valuable if your friends are there.
True.
When they join, the platform becomes more valuable to you. If third-party developers start building apps that integrate with the platform, it becomes even more useful, which attracts more users, which in turn attracts more developers. It's a positive feedback loop that just multiplies the platform's overall utility.
And that's the classic strategic advantage that pipeline businesses just can't replicate. You aren't competing on one feature anymore, you're competing on ecosystem scale and connectivity.
Right. A competitor might copy the feature set.
But they can't instantly replicate that rich network of established connections, users, and all the complementary applications.
That accumulation of network capital is why successful platforms often trend toward winner-takes-most market structures. Once those network effects solidify, the barrier to entry becomes enormous. It makes it almost impossible for a latecomer to achieve any meaningful scale.
And this translates directly into financial performance, which is a key takeaway for any business student listening. Research consistently quantifies this benefit. It shows that companies adopting platform models see drastically higher valuations, often 2 to 3 times higher than comparable product-centric firms.
And we know why. Platform economics fundamentally transform revenue streams. You move from a single source of revenue just selling your product to multiple sources.
So you've got subscription fees, transaction fees.
Subscription fees from the core platform, transaction fees from activity between users, and revenue sharing from third-party applications built on your APIs. This multiplier effect that's generated by the ecosystem results in higher, more sustainable growth expectations for investors, which justifies those lofty valuations.
But to sustain that massive, unpredictable ecosystem growth, the platform architecture itself needs some pretty rigorous technical foundations. What are those technical requirements?
Above all, the platform needs flexibility, robustness, and scalability. It has to handle vast numbers of users and partners plugging into the core without causing system instability. This demands a layered, modular design.
So a reliable core that never changes, but innovation layers on top that are constantly changing.
That's it. And crucially, the architecture isn't just code. It also involves governance. How do you set the rules for the ecosystem?
That's a huge tension. Right. You need radical openness to spur innovation from outside, but you also need stringent control to ensure security, quality, and trust.
That tension is where platforms live or die. Firms like Apple and Google, they manage this tension through strict governance frameworks. They define clear APIs, maintain detailed documentation, and implement curation processes like the App Store approval process that ensure quality, security, and alignment with the platform's overall value.
So governance involves security protocols, quality assurance, policies that maintain trust.
All of it. If people don't trust the platform to protect their data, or if the quality degrades, the ecosystem just fractures. So the art of platform governance is ensuring that external partners can innovate freely in sync with your standards and value proposition.
And this shift is so powerful that, as we saw with Alpha Bank, it's even being forced onto traditionally closed sectors. Let's look closer at open banking as a specific platform ecosystem example because it directly relates to compliance and regulation.
Open banking is a perfect example of platform architecture being mandated by governmental regulation. Traditional banking was the ultimate closed-off pipeline.
The vault.
Exactly. When fintech began to disrupt the market, regulators in the EU introduced directives like PSD2, the Payment Services Directive 2, and this regulation required banks to securely open up customer data and payment capabilities to licensed third-party providers via standardized APIs.
So it immediately forced banks to adopt a platform mindset.
It did. The government essentially told banks, your core banking services are now public utilities, and you must treat them as a foundation for innovation, not a vault.
Wow.
And this created a massive regulated platform market. Licensed fintech developers now consume these open APIs to build services that no single bank could ever develop internally.
Right, like the new features we use daily. Apps that aggregate a user's accounts from multiple financial institutions into one unified dashboard, giving you a complete view of your finances.
Or payment initiation services, which allow customers to pay merchants directly from their bank account, bypassing traditional card networks.
So banks had to scramble. They had to race to build developer portals and expose dozens of APIs for payments, account info, foreign exchange rates.
It was a costly and difficult compliance process for sure, but it immediately invited outside innovators into their ecosystems.
The challenge and the strategic takeaway here are massive, though. For the consumer, the benefit is undeniable. A richer variety of personalized, faster financial services.
But for the bank, there's a genuine risk of disintermediation. If third-party fintech apps own the entire customer interface, the user experience, the bank risks being relegated to a back-end utility, just a dumb pipe that processes transactions.
And they lose that direct customer relationship and loyalty.
Correct. So leading banks mitigate this risk by actively curating high-quality partners, ensuring they maintain high levels of trust, and often developing their own sophisticated marketplace ecosystems that integrate the best third-party services directly into their existing customer platforms.
So they can't just open the doors. They have to actively manage their role.
They do. And the strategic takeaway for you, the learner, is vital. Platform architecture is not exclusive to big tech. It unlocks innovation and drives competitive necessity, even in highly regulated traditional sectors, by transforming isolated service providers into powerful networked hubs. It uses mandated interoperability to survive and hopefully thrive.
Okay, so if the platform is the strategic architecture, the bridge connecting all the participants in the ecosystem, then APIs are the technical infrastructure. They're the standardized roads that allow the traffic of data and services to flow smoothly across organizational boundaries.
Hmm.
So what exactly defines an API for a business student?
An API, or Application Programming Interface, is defined as a service contract. It is a standardized, controlled method for one piece of software to request specific data or functionality from another system without needing to know how that other system works internally. It establishes the rules of engagement.
That contract analogy is really important. It means you guarantee that input X will produce output Y, and that contract has to remain stable even if the internal system behind it completely changes.
Exactly. APIs are the ultimate connective tissue. They allow disparate systems, often built at different times, using different technologies by different vendors, to work together seamlessly.
So digital transformation at its core is really just API-driven interoperability.
I mean, we are not exaggerating when we say this. Industry analysis shows that API call traffic now constitutes well over 80% of all internet traffic. Programmatic interactions are the default mode of modern commerce.
And from a strategic perspective, this is where internal technical capability gets translated into an external reusable asset. APIs turn internal business capabilities into reusable products or building blocks that can be leveraged rapidly.
The abstraction is the power. The API frees developers from reinventing the wheel. The classic example is integrating mapping services. If you are building a delivery app, you don't need to spend millions developing global map data, routing algorithms, and Street View imagery. You simply call the Google Maps API. You pay for the service, but the heavy lifting is handled by another specialized firm.
And internally, APIs ensure modularity. Different teams can reliably integrate with a central customer info service or a payment gateway through a single, well-defined API without suffering that tight internal coupling.
And this externalization of services through APIs is where the money is made too. I mean, firms like Stripe and PayPal have entire business models built around providing core financial functions as APIs.
Yeah, and cloud giants like Microsoft and Amazon generate massive revenue by selling access to their internal capabilities, storage, compute, database queries, all through a library of paid API calls.
And since not all interactions require the same level of trust or openness, organizations strategically categorize their APIs. We generally discuss three main categories, which reflect a continuum of openness.
First, the bedrock, private APIs.
These are used exclusively within the organization to connect internal systems and services. For a multinational company, this might be a standardized internal API for inventory lookup or employee authentication. They ensure all internal applications use consistent high-quality functions.
And these private APIs are the essential groundwork for any later external exposure, right?
Absolutely. If you design your internal APIs well, with good security, documentation, and versioning, you ensure that if the business strategy shifts, you can easily turn that internal capability into an external partner-facing product without a complete rewrite.
Okay, so the second category is partner APIs.
These are shared with specific authorized B2B partners under formal contractual agreements. This supports strategic alliances. Think of major logistics companies like FedEx or UPS. They offer secure APIs to high-volume clients, allowing those clients to integrate real-time tracking, automatic shipment scheduling, and label generation right into their own internal warehouse management systems.
Or like a software integration. An HR system might offer a partner API so that a specific payroll processing company can securely access necessary employee data.
Exactly. These APIs solidify strategic partnerships, ensuring that two distinct firms can operate as a seamless whole for the customer.
And finally, the game changers. Public or open APIs.
These are what fuel the broader API economy and the platform ecosystem. They're available to any external developer, often with registration or usage fees, or under a tiered subscription model.
So Stripe and PayPal, as you mentioned, offer public APIs for payment processing.
Right. Social media companies opened APIs that fueled the growth of third-party management and analytics tools. This category maximizes external innovation and reach.
The immense value of APIs, regardless of the category, is how they accelerate development speed through something called composability.
Composability means organizations can assemble entirely new services rapidly, focusing only on their unique intellectual property and leveraging existing, API-accessible services for everything else.
which drastically reduces time to market. The Uber case study remains the clearest example of a successful technological mashup.
Hmm.
Uber built its initial service so rapidly, not by coding everything from scratch, but by combining existing best-in-class API-accessible services. Google Maps for navigation, Twilio's API for SMS communications, and Braintree's API for payment processing.
And if they had tried to build those systems internally, the mapping, the payments, the comms, their launch would have been delayed by years. APIs enable hyperspeed market entry by creating leverage over other specialized service providers.
And the indirect strategic benefit is huge. Salesforce doesn't have to hire R&D teams to build thousands of niche tools for, say, specific veterinary practices or specialized B2B accounting needs.
Right.
Instead, third-party developers build those apps on the Salesforce App Exchange, extending the platform's functionality via its API. This creates immense stickiness for Salesforce, making the platform far more valuable to its customers without direct capital investment in those features.
You know, we have to discuss the historical linchpin of this entire philosophy.
Here.
The Amazon API mandate issued by Jeff Bezos back in 2002. It wasn't a technical guideline. It was a management decree.
It's the stuff of corporate legend. Bezos issued a zero-tolerance rule. All teams must expose their data and functionality through service interfaces, APIs.
Period.
All internal communication between teams must use these APIs. No direct links, no backdoor database access. And the APIs had to be designed as if they would be opened externally to the public.
And the underlying threat, as it's often recounted, was that those who didn't comply would be fired. That high-stakes enforcement really underscores the strategic value leadership placed on forcing modularity and interoperability internally.
The technical consequences were immediate. It forced internal teams to act like autonomous businesses, becoming service providers to one another.
Yeah.
Teams could no longer rely on tacit communication or tightly integrated code. They had to rely on a clearly defined standardized API contract. This enforced modularity created an incredibly efficient, scalable architecture.
And here is the strategic revelation. When Amazon later realized they had perfected the infrastructure, storage, compute databases internally, they could simply externalize that architecture as products. The groundwork was already complete because every internal team had been using the system as if it were public.
Which led directly to the creation of Amazon Web Services, AWS.
The multi-billion-dollar cloud industry leader, born purely out of an internal mandate for architectural efficiency and standardization via APIs.
So the lesson for every company is that internal interoperability by design, enforced through API governance, is what unlocks the possibility of unprecedented growth and new business models that were previously unimaginable in a tightly siloed system.
But this requires immense technical and management rigor. When you open doors, you must ensure they are locked securely. So robust API management tools are non-negotiable gateways that manage traffic, develop key management systems, versioning protocols, and monitoring to detect misuse.
Let's talk about versioning for a second.
Yeah.
Why is API versioning such a critical strategic consideration?
Because the API is a contract. If you, as the provider, change the format or functionality of the API, you risk breaking every single external application that relies on it.
Oof.
Strategic API management requires rigorous versioning, like API v1.0, v2.0. You have to manage the deprecation process, ensuring that when you roll out a new, superior version, you continue to support older versions for a specified period, giving your partners time to migrate. Failure to manage versioning reliably is a platform killer. It destroys partner trust and ecosystem stability.
So APIs are the cornerstone of the platform ecosystem, but the physical structure of the underlying software also needs to change to support this speed, which brings us to the architecture required for agility.
So if we accept that the strategic objective is speed, resilience, and ecosystem participation via APIs, then we must adopt modular systems thinking. This is the structural requirement for the speed and composability that APIs promise.
And modularity, to put it simply, is designing systems as loosely coupled, interchangeable components for greater organizational agility and resilience.
Right. It's about maximizing high cohesion within each component while ensuring loose coupling between them.
And this represents a dramatic architectural departure from the traditional system most large organizations were built on.
The monolith.
The monolith liability. We introduce it with Alpha Bank, but let's look deeper at the pain points for the MIS student. What does it actually mean to work inside a big ball of mud?
In a monolithic architecture, everything user interface, business logic, data access, reporting, is interwoven and deployed as a single unified codebase. It's one giant executable file. And while this simplifies development early on, especially for small startups,
It quickly becomes an operational nightmare at scale.
the core problem is tight coupling. If the team responsible for processing customer loyalty points needs to make a small fix, because that code is intertwined with the payment processing and inventory management, they risk introducing unintended side effects across the entire application.
And that fear of breaking the monolith, it just slows down all development. And scaling is terribly inefficient. Imagine your system is under peak load, but only one function like the video streaming module is actually strained. In a monolith, you have to spin up an entirely new massive instance of the entire application.
Wasting CPU, memory, and licensing costs on services that aren't even being used.
Exactly. And deployment is agonizingly slow. To update one small feature, developers must test and redeploy the massive single monolithic application. This pushes release cycles from daily or weekly to monthly or quarterly.
Which is a death knell in the digital age.
The history confirms this liability too. Legacy system replacement projects and the massive multi-year attempts to rip and replace a monolith have failure rates estimated as high as 90%.
Monoliths resist change not because the people are bad, but because the structure is inherently brittle and interlocked.
So the modular modern answer to this is microservices architecture.
Right. Instead of one giant application, the system is decomposed into many small independent services. Each service is dedicated to a specific business capability, runs in isolation, and communicates over a network via its own well-defined APIs.
Okay, let's break down the comparison precisely, because understanding this contrast is so crucial for anyone entering the technology sector.
Okay, let's do it. Structure.
A monolith is one unified codebase, often using a single database. Microservices are many small, independent services, potentially using polyglot persistence, each service choosing the best database for its needs.
Coupling. A monolith is tightly coupled. A change in one area affects others.
Mhm.
Microservices are loosely coupled. Changes are isolated to that specific service, communicating only through that stable API contract.
What about agility and deployment? The monolith requires all features to be deployed together in a massive release cycle.
While microservices allow independent teams to develop, test, and deploy their service update without coordinating a global release.
In scalability, you scale the entire monolith, wasting resources.
Whereas you scale only the necessary microservice. For instance, only scaling the checkout processing service during Black Friday load, which optimizes resource usage significantly.
And most critically, resilience and fault isolation.
If a bug appears in a monolith, it often leads to a system-wide crash. With microservices, if the inventory service fails, the user profile service and the payment service remain operational. The system is designed to gracefully handle partial failures, which is vital for any large global platform.
Okay, but for the business student, we have to emphasize the major trade-off. It's not a free lunch, is it? Microservices introduce enormous operational complexity.
Absolutely not. It's not a free upgrade. You trade the complexity of a tangled code base for the complexity of a distributed system. Suddenly, instead of managing one application, you're managing hundreds of distributed parts that have to communicate reliably over a network.
And that introduces issues like network latency between services, the difficulty of managing distributed transactions across multiple databases.
And the necessity of sophisticated tooling. This is where modern tools like containerization with Docker and orchestration with Kubernetes become absolutely essential. Kubernetes is the technical tool that manages the deployment, scaling, and networking of those hundreds of independent microservices.
Without those tools, it would just be chaos.
Complete chaos.
Yeah.
You need robust practices in DevOps, sophisticated monitoring systems, we call them observability tools, and often a service mesh to manage service-to-service communication, security, and error handling. This requires a significant investment in platform engineering talent.
And the structural change in the software, it dictates a change in organizational structure. This is often summarized by Conway's law,
which states that organizations design systems that mirror their internal communication structures. So if you break the software, you must break the teams.
Modular architecture requires cross-functional teams organized around business capabilities. You can't keep the old siloed model, the database team, handing off work to the front-end team, who hands off to the back-end team.
No. Instead, you create an autonomous, empowered, cross-functional payments team or search service team that owns their microservice end-to-end, its UI components, its business logic, its database, and its deployment pipeline.
And this autonomy, enabled by the architectural decoupling, allows for truly independent and rapid innovation. Amazon's two pizza teams are a great example of this.
Small groups that own their service fully, allowing for continuous independent deployment without external coordination bottlenecks.
And the most famous case study proving the imperative of this shift has to be Netflix. Their migration from a monolithic DVD rental system to a global streaming platform is the textbook example of the microservices journey.
Yeah. In the late 2000s, when they were scaling their streaming service, Netflix was running a massive Java monolith that handled everything. The tipping point, the strategic forcing function, came in 2008. A major database corruption in that single monolithic system caused the entire Netflix service to be down for 3 full days.
3 days of outage for a subscription service is a catastrophic failure. It proved the monolith was a single point of failure and fundamentally incapable of scaling or recovering globally.
And the response was radical. Netflix embarked on a multi-year migration, incrementally breaking the monolith into hundreds of microservices, each dedicated to a discrete function user profile service, recommendation service, billing, streaming, playback. And they simultaneously made the strategic choice to move their entire infrastructure to the public cloud, specifically AWS.
The results are just astounding. Today, Netflix runs well over 700 microservices. Because of that architectural decoupling, their engineers deploy code multiple times a day, not once a month.
And that speed allows for continuous A/B testing and rapid feature iteration.
And their resilience is legendary. If the recommendation service fails, users can still stream videos. The failure is isolated.
That agility and resilience were simply physically impossible under their previous heavy interlocked monolithic structure. Modular architecture allowed Netflix to evolve at the speed of software development.
And this principle leads directly to the concept of the composable enterprise. Modularity is the foundation of composability, where organizations design their technology and teams in a building block fashion to rapidly assemble new services.
Forrester research confirms the strategic advantage here. Organizations that fully embrace composable modular architectures achieve substantially faster delivery times, often 40 to 60% faster in delivering new digital capabilities compared to those hobbled by monolithic stacks. For you, the business leader of tomorrow, understanding microservices is understanding the structural prerequisite for true enterprise agility.
So we've established the what platforms, APIs, and microservices, and the how modularity and interoperability. Now we return to the why for the business student. The core strategic principle is unbending. Technology architecture must be an accelerator of business strategy, not a bottleneck or an afterthought.
Absolutely. Architecture cannot be an end in itself. If you build the best microservices architecture, but your business planning cycle still lasts 18 months, you gain no strategic advantage.
Right.
Modern enterprise architecture, or EA, has shifted its focus. It's no longer about policing standardization for its own sake. It's outcome-driven, focused entirely on enabling continuous transformation and business agility.
And this demands a shift in thinking for CIOs and technology leaders. The question changes from what technology do we need to control to how can we structure our technology to enable faster, safer, and cheaper innovation in response to evolving business needs.
This brings us to a crucial architectural framework developed by Jean Ross and her colleagues at MIT. It's the recognition that a successful digital enterprise needs two distinct complementary structures: a stable operational backbone and a fluid digital platform.
This speaks directly to the dual needs of the enterprise: efficiency and speed. The operational backbone is the stable, efficient core. These are the standardized, integrated systems, the ERP, the foundational HR, the core transaction processing systems designed for reliability, security, and standardized efficiency. It's like the high-speed infrastructure highway.
And the digital platform is the fluid innovation layer built on top. This is the repository of reusable, API-enabled, cloud-based components, the services and vehicles on that highway. This layer is designed for speed and external engagement.
The key here is reusability. If a company wants to launch a new mobile application or enter a new market, they don't start from scratch. They reuse the existing customer authentication component, the billing API, and the customer profile service directly from the digital platform. This ensures consistency, reduces redundant development, and dramatically speeds up deployment time.
And this framework is the blueprint for strategic alignment. The architecture must enable the unique strategic choices of the firm. Let's look at Tesla. Their strategic choice is continuous product improvement post-sale, adding features like advanced battery management or self-driving enhancements via over-the-air updates.
That strategy is entirely dependent on an architectural decision, treating cars not as fixed machines, but as software platforms with modular, updatable firmware. If their architecture resembled a traditional automaker's tightly coupled internal electronics, that strategy would be impossible to execute.
Conversely, we have to heed the warning of strategic misalignment, which often costs billions. Consider General Electric's attempt to pivot into a digital industrial leader with their Predix platform initiative.
Ah, yes. GE's strategy was ambitious, become a platform that connected industrial assets, turbines, engines, machinery, and allowed partners to build industrial Internet of Things applications on top.
But the strategy failed because the architectural foundation and internal skills were just not ready. They tried to build a monolithic, GE-centric platform that lacked the true modularity and ecosystem-friendly design necessary.
So their internal teams struggled to make the shift from building massive physical products to designing nimble, reusable software services.
Exactly. The strategy was platform-focused, but the architecture and internal culture were still deeply pipeline-focused. The financial and strategic failure of Predix is a stark reminder that architecture must support ambition.
So to manage this strategic alignment without stifling innovation, leadership must implement federated governance. This is vital.
It is. Governance should set guardrails, non-negotiable standards for APIs, security protocols, and versioning, but without arbitrarily dictating internal tools, like mandating a single programming language or operating system for every team.
The goal is to give autonomous teams the freedom to use the best technology for their specific service, for speed and innovation, while ensuring the interfaces between those services remain standardized and secure.
Right, for consistency and reliability. This delicate balance is what makes a digital platform robust, yet nimble.
And the most nimble firms manage this alignment through coevolution. The technology roadmap has to directly mirror and sometimes even preempt the business strategy roadmap.
So, for example, if the business plan calls for launching a new product line that utilizes advanced machine learning features within 18 months, the technology roadmap must proactively include the step. Develop and integrate an AI as a service capability into the digital platform by Q4. This ensures the architecture is always ready to accelerate the business strategy.
And conversely, new architectural capabilities can open up new strategic options.
How so?
Well, once an organization successfully modularizes its sensitive customer data via a secure API, it might realize it can now safely sell anonymized analytics insights to partners, creating an entirely new revenue stream that wasn't strategically possible under the old, tightly coupled system.
Ultimately, architectural choices like investing in a digital platform or reworking core systems from monoliths to microservices are senior executive decisions. If the technology side is modernizing everything, but the business side is still planning in multi-year rigid cycles, the value of the architectural improvement will be lost. The processes, the culture, and the talent must evolve in lockstep with the technology architecture.
The major career takeaway for you, the learner, is this. You have to recognize that technology architecture today is a competitive core differentiator. Your ability to think modularly, understand API governance, and contribute to a platform strategy, whether you are in finance designing a new pricing structure or in marketing optimizing the customer journey, will determine your value in the modern organization. Architecture has moved from the basement of IT to the CEO's core agenda. Hashtag tag outro.
So let's synthesize our deep dive. We move from understanding closed, linear pipeline systems to open, networked platform ecosystems, recognizing that modern competition demands managing an entire network of participants.
Right.
We defined APIs as the essential service contracts and interfaces required for interoperability, allowing systems to communicate fluidly across organizational boundaries.
And finally, we saw how modular architecture, exemplified by microservices and governed by Conway's Law, provides the structural agility necessary for continuous innovation and resilience. And our opening case, AlphaBank, proved that digital survival requires intentionally building flexibility into the core architecture through platforms and APIs. They transform their foundation from a brittle monolith into a springboard for ecosystem innovation, proving that the technical choices you make today define your strategic possibilities tomorrow.
This foundational knowledge is just so crucial. Understanding the structural implications of these architectural choices, modularity, interoperability, and platform governance is what will separate future organizational leaders from those simply maintaining outdated systems.
Thank you for joining us for this intensive deep dive into modern enterprise architecture. We hope you feel thoroughly informed and ready to apply these concepts in your studies and your career, ready to tackle the inevitable migration discussions in your first job.
Mm-hmm.
If you enjoyed this conversation and the insights we shared, please make sure you like, subscribe, and share this deep dive. And don't forget to check the description for access to additional resources that complement today's discussion.
Next time, we're moving down a layer. Before you can worry about APIs and microservices communicating across a platform, you need to understand the underlying medium that makes it all possible, the infrastructure that routes the data.
Yep. Our next deep dive will be Chapter 6, The Bits and Bytes of Computer Networking. We'll explore the fundamental physical and logical infrastructure that ensures platforms and APIs can actually communicate seamlessly across your office, across a data center, and across the globe.
Looking forward to it.
For now, consider this reflective question tied directly to today's material. Think about your chosen career path, whether in finance, marketing, or information systems. How will your ability to think modularly, leverage platforms, and enforce strong API contracts determine your competitive advantage and the agility of your team in the next 5 years?
That's a good one to think about.
That's a wrap on this episode of Emerging Technologies and Innovation Strategy. Keep questioning, keep exploring, and remember, every disruption starts with curiosity. Until next time, stay ahead of the curve.